This video describes Pic2Plot, an AI tool to generate floor plans from house pictures.
Use case. So for that we need to select our house images. Let's select the house images and we can ask, can you convert my images to floor plan? So the main focus was to get good accuracy in a very less time. We can see, yeah, here is our output and we see it's a 1 BHK flat and it was able to draw that in a very faster way. So we can ask, can you give me a floor plan for 3-bed 2-bath? So let's see the response. This uses a rack system and find the similar match. So we can see that there are 3 different, like the top 3 matches. So we can go to with the third use case. We can use a home data set and yeah, we can select some image and we can ask, can you suggest help tips for my room? So what does it do? It analyzes the room architecture and it gives you some suggestions based on your room. So here we go. The result, it suggests that there is no visible windows and it suggests that the room is having a darker theme and consider having calming themes like blue, green and etc. So it has add indoor plants. And the fourth use case is like it can be used for websites like Zello, wherein we can select some images. Okay, let me select some images and we can write, can you convert my images to a real estate description? So it does give you a real estate description based on the images that you provided. So here is the real estate description and also
The second point in the hackathon is to describe our experience building the entry. We started off using a project management software called Basecamp, defining what Pic2Plot would do, which is building floor plans from pictures, and then breaking down outcomes that we expected to have to tackle as part of this project. The team read through that and coordinated in chat. This is asynchronously. Everyone came from different places in the world, including New Zealand, Australia, and Maryland, and Seattle. And we ran into a couple of challenges and limitations in our experience, which Tiffany summarized well here. The first one being the spatial LLM model requires a very specific environment. And deploying that within Azure with the available free tier environments was challenging. And the Slammer 3D point cloud reconstruction model, which is used in lieu of photos, that was most readily available for generating floor plan. But as you may have seen in the image when you saw that first floor plan, did it actually match what was there? Well, the Slammer 3D point model is what decides that, and it does not necessarily have the most consistent responses. But we ended up continuing on with our project, and the reason for that relates to the third point, which is a next one. Companies like Zillow and Redfin, they have this data. They can provide a feature to people who want to remodel their homes, etc. But what was really interesting is beyond that original vision, there were a lot of great inspirations that come from a simple start. And so one idea, for example, is generating a floor plan for the entire property. This doesn't exist today. There's no model that does that. It's only indoor houses that are available. And Tiffany here ended up bringing up some great ideas as well, bringing in local regulations, design standards that maybe aren't general or more specific, designing a functional design from scratch, right? People who want to maybe get new ideas about a specific space in consideration of the floor plan, that can be something that the LLM provides. And different experimentation, right? Enlarging the bed size, being able to say, hey, what does my room look like if I move the bed over there and got a king size bed? One of the things with integrating Slammer is that the advancements in this would be really beneficial to the project in terms of what we would get in spatial reasoning and accuracy, and especially measurements. That enables a lot more in terms of what we could do with knowledge about the floor plan of a location.
Talking about the architecture, agentic multi-model architecture is something that we used. It's built on the AML workspace. So we have multi-models, like based on the complexity of the use case and dependencies, we choose the models. For example, PHI3 is a very small model and with good latency, it just classifies which tool we need to redirect. So, and also when we take, there are 3 image processing tasks, but we used Llama 3.2 vision and 4.1 based on, because Llama 3.2 vision health recommendation need not analyze the in-depth of the room, like especially the connections between the room, so it does not require a huge model to do that. But 4.1, it need to analyze the room connections and it need to give to the DALI. So it's very important that we use a good model over here rather than here. So in this way we choose the models. And also for the text input to floor plan, also we tried several models like floor plan LoRa, but it does require a high-end GPUs to get it deployed. So to overcome that, we used the Kaggle dataset, which has the floor plans over 1,000 images, and then we converted those as the labels to the embeddings, and so that based on the embedding result it will retrieve the images from the Azure.